welcome to another episode of Statistics and Sweats. I hope you guys watched the video from last week. If you didn't, I hope you do soon. If you are not planning on watching an episode this week, you're wrong. I need you to watch this episode. I love that I'm calling them episodes. But anyway, there was something that I should have went over last week that I didn't go over that I should have, and it's the Monty Hall problem. It's my favorite thing to talk about in statistics, and it leads up to my deal or no deal lesson that we didn't get a chance to do, and I'm really, really heartbroken about it. But I don't know about you guys, but I have a morning routine, and part of my morning routine is putting on CBS from 10 to 12, and I watch Let's Make a Deal with Wayne Brady, and then I watch The Price is Right with Drew Carey. So the Monty Hall problem comes from Let's Make a Deal. And it's this age-old question. You can look up Monty Hall problem if I don't do a good job explaining it. I can actually put another link on the Google Classroom that really explains it probably a lot better than I will, but I'm going to do my best. But let's introduce it. So this is what one of your discussion posts was about. One of your discussion posts was about 3 curtains, and one of them has a car, and 2 of them have a zonk. I don't want you watching me explaining it before you answer that. So, pause or stop watching. I don't care what you do. Answer the discussion post first before you watch me explain. So, you were on Let's Make a Deal. You don't have to pause it. You were on Let's Make a Deal. And one of these doors, I call them curtains, one of these doors has a car behind it. And the other 2 have a zonk. So the classic way that this has been described is 1 is a car and 2 are goats. But some of you might want a goat. So I am saying it's a zonk. So one of these has a car. 2 of them have a zonk. Kirk, pick a door. 1 through 3.
1.
1. Great. Perfect. Kirk is picking door number 1. So Mr. Wayne Brady. Is that my computer? Oh, it's my computer. My computer's making weird noise. But anyway, so Mr. Wayne Brady says, you can pick one of these doors. Kirk's like, got you. Door number 1. Then Mr. Wayne Brady is like, well, let me show you what you didn't pick. And he opens, let's say, door number 3. He opens door number 3, and it's a zonk. So now you have what you feel like is a 50-50 chance of getting the car. You feel like it's 50%. Well, let's start from the beginning. So in the beginning, you had a 1/3 chance of being right and a 2/3 chance of being wrong. So now he said, oh, door number 3, that's a zonk. You're beat. And he gives you the option to switch. So the question is, do you stick with your gut or do you switch? What would you do? I kind of have to give it away, but statistically, you have a higher chance of winning the car when you switch doors. And this probably will not make sense at first, because it doesn't, because everyone's like, oh, trust your gut. Trust your gut. You gotta trust your gut, right? Let me break it down. 1/3 chance of being right, 2/3 chance of being wrong. That probability does not change because he knew which door to open. Because he chose and he had prior knowledge to open door number 3, you still have a 2/3 chance of it being in these 2 doors. So I know it's not here, so now this has a 2/3 chance of it being in door number 2, and you still have a 1/3 chance of it being in door number 1. So statistically, you should switch. You have a higher chance of winning when you switch. And this still probably makes no sense. And that's okay, because I'm going to break it down. So let's say, if it's door number 1, you got the car, zonk, zonk. if I pick one, I'm gonna win and I shouldn't switch. Cool. If I pick two, I'm gonna lose and I need to switch. In order to win, if I pick door number 2, I need to switch. And then last, if I pick door number 3, I'm going to lose unless I switch. So 2 out of the 3 times, I need to switch in order to win. Only 1 out of the 3 times does sticking with my gut actually get me the prize. So that's where the 2 out of 3 comes from. And I could do it with door number 2 and it's still going to be the same. I could do it with door number 3 and it's still going to be the same. You only win when you stick with your gut 1 out of 3 times. So that's Monty Hall. Again, there's a really awesome video that I kind of stole a lot of these ideas from that I'll post when I post this. But that's Monty Hall. One of your discussion posts is about it. I really hope that you answered the discussion post before watching this. But what can you do? We're in quarantine. All right, so another thing I noticed last week, and I actually want to backtrack a little bit. I was going to move forward, but no, we're going to spend a little bit more time with compound probability. And if you've been taking notes at home, awesome. I have something for you to write down. I noticed that like a deck of cards is kind of foreign to a lot of you, so I wrote down all the things you need to know about a deck of cards. And if you want to pause and copy this down, that would be very wise. So you probably pause by now if you need to. So things you need to know. There are 52 cards in a deck of cards. Never, ever, 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 ever include jokers. Jokers just aren't part of adult card games. Doesn't happen. You're not going to play blackjack and get a joker and win. That doesn't happen. So we never include jokers. So there's 52 cards total. 26 of them are red and 26 of them are black. That means half are red and half are black. Then we go into the 4 suits. So I noticed that I think clover was a suit that some people thought, and it wasn't just one person. It was at least like 10 people that thought clover was a suit. No. The suits are heart and diamond. They're red. Spade and club. They are black. So heart and diamond, there's 13 each. So a fourth of the cards are hearts. A fourth of the cards are diamonds. A fourth of the cards are, does that say spades? Yeah, spades. And a fourth of the card are clubs. So out of the red cards, there's 2 suits, and out of the black cards, there's 2 suits. So half are red, half are black, a fourth are heart, a fourth are diamond, a fourth are spades, and a fourth are clubs. It is important to know the exact amount of red cards and spades and hearts and diamonds and clubs, and we're going to get to that in a little bit. But other than that, the other things you should know are what the face cards are. And the face cards are cards with faces on them. Yeah. So it's going to be Jack, Queen, and King. So there's 3 types of face cards, and there's 12 total. So there's 3 in each suit, and since there's 4 suits, there's 12 total. The last thing I need you to know is that there are 4 of every number or face or whatever you want to call ace. I call it a number. There's 4 of each in every deck. So there's 4 aces, there's 4 twos, there's 4 threes, there's 4 fours, there's 4 5, 4 sixes, 4 sevens, 4 eights, 4 nines, 4 tens, 4 jacks, 4 queens, 4 kings. 4 of each specific number or face. So that's a deck of cards. This is something I need you to know. If you ever want to play poker, or if you ever want to play blackjack, what's another card game?
Go fish.
If you ever want to play Go Fish, without jokers, not playing with jokers, then important, please know this. So I'm going to take the remainder of this time just to kind of go over some compound probability questions that may or may not be on an assignment I'm going to post on tomorrow. Don't use a pen. So let's say I pick a red card. I replace it. Remember, that means I put it back in the deck. And then I pick a black card. Like, what's the probability of that happening? So I'm going to say, replace, yep. is how probability is asked. It has the little p, and then it's going to have, like, in parentheses, what's going on. And I'm always going to put whether you're going to keep or replace it if it could be an independent or dependent event. So red, replace, black. So like I said, there's 26 red cards out of 52 total. Compound events mean you multiply. Don't add them, multiply. And if I replace it, that means there's still 52 cards. And nothing affected the number of black cards, so there's 26 black cards. This is a catastrophe. There are a lot of big numbers, and if you put the big numbers and you did 26 times 26 over 52 times 52, you're going to get an absurd number, but it's going to be correct. What I'm going to do is I'm going to show you a much more easy on the brain way to do it so that you're not doing a ton of typing in your calculator, because most of you don't have like a scientific or graphic calculator at home and you have to use this guy. So I want you to use your cell phone as least, not as much as possible. I don't know. Whatever. So 26 over 52, I could divide them both by 26 and get 1/2. Or I could remember from the beginning that half the cards are red. So I just 1/2. Cool. Half the cards are black. 1 times 1 is 1. 2 times 2 is 4. So I have a 1/4 chance of getting red, replacing it, and then getting a black card. And that's how that's done. Cool. So what happens when it is a dependent event and I keep a card? So let's do the same problem, except now instead of replacing the red card back in, we're going to keep it. All right, same question, but now I'm keeping it. So again, 26 out of 52 of the cards are red. But now, because I kept my red card, I do not have 52 cards. I have 51 cards. The number of black cards doesn't change, though, because I didn't pick out a black card. I just picked out a red card, so it's still 26. This is when things get a little bit more complicated when you try and simplify. So what I'm going to do is I'm going to do what I know, right? I don't know the simplified version of 26 over 51, if there even is one, but I know, because of the previous problem, 26 over 52 is 1/2. Cool. And now I'm here. If you're really good at simplifying, you can cross out this 2, divide this by 2, and make it a 13. If you know what I just said, do it. If you don't, I'm going to show you how I'm going to do it. 1 times 26 is 26. 2 times 51 is 102. If you got this as an answer, cool. If you multiplied the 26s and the 52 and the 51 and got a really big number on the top and the bottom, I accept that too. But let's focus on this. They're both even numbers, so I'm going to divide it by 2 because I know I can do that. So 26 divided by 2 is 13, and 102 divided by 2 is 51. This is the most simplified version, but again, these are both good answers, and even if you multiplied everything up here and got an answer, that's okay with me too. All right, cool. So that's when just the denominator is affected. Now I'm going to show you what happens when both the denominator and the numerator are affected. So heart, then heart. So what's the probability of a heart keeping it and then a heart? So again, it's going to look like that. P, heart, keep, heart. Probability of having a heart in the beginning, well, grabbing a heart in the beginning, is going to be 13 over 52, because there's 13 hearts in a deck, and there's 52 cards. But here's the thing, if I keep a heart, there's no longer 52 cards. There's 51 cards. And there's no longer 13 hearts. There's 12 hearts. I hope that makes sense. So 13, there's no longer 13 hearts in the deck because I took one out, so now there's 12. There's no longer 52 cards in the deck because I took one out, now there's 51. What I'm going to do is I'm going to simplify what I know. And as you go through this and as you get more repetition and more practice, you're going to notice that 13 over 52 is 1/4. And I know that because 1/4 of the cards are hearts. So 1/4. I could simplify 12 over 51. I know my 3 divisibility rule. It's actually my favorite divisibility rule. I know that 1 plus 2 is 3. 3 is divisible by 3. I know that 5 plus 1 is 6. 6 is divisible by 3. So I'm actually going to simplify this even more. I'm going to go 1/4 times 12 divided by 3 is 4. 51 divided by 3 is 17. So again, if you multiplied this and then this, or if you multiplied this and then this, or if you went really simplified and you multiplied this by this, you're going to get 4 over 68. And we can simplify that even more. If you noticed up here that I have a 4 here and a 4 here, I can cancel them out because they're diagonal from each other. And the most simplified version is 1 over 17. And again, I don't need it to be simplified. If you got, let me do this real quick. So if I did it from the very beginning, and I was like, I'm not messing around with simplifying. I'm not taking a chance of being wrong. She's going to accept a non-simplified answer. Let me just do what I know. 13 and 12. $156. And then I would do 52 times 51. Come on. And I get 2652. If this was your answer, great job. I don't mind. I really don't mind. If this is your answer and you just don't know how to simplify it to get here, I'm really okay with it. We are in quarantine. Like, you gotta have a little wiggle room. Okay, so that's when the top and the bottom, or the denominator and the numerator, change. I got 2 more little problems to go through, and then I will leave you alone for the rest of the week. Expect 2 more assignments to be posted and a quiz posted on Thursday. I'm hoping to get the assignments out to you tomorrow. All right, so let's do face, replace, 8. So we got a face card, replace, and then just an 8. What are the chances of that happening? Okay. So face cards, we said there's 12 out of 52. If I'm replacing it, then it stays 52, right? There's 4 8s. This is when simplifying is going to be your best friend, okay? 12 over 52, that simplifies to 3/13, and 4 over 52 simplifies to 1/13. Multiply across, multiply across. You actually can't simplify that anymore. 3 over 169. That's your answer. Or again, if you did it up here and you did 48 over, I think it's 2704. I'm not 100% sure. Or if you just multiply the top and the bottom, these are the same answer. I do not mind. I'm really okay. All right, one last problem, and then I'm going to let you do your thing. Thank you for tuning in this week. This is a special case, and I almost always put it on a quiz. I almost always put it on a quiz, and it requires you to know what suits are what color. So remember, heart and diamond are red, spade and club are black. So let's do this. So what's the probability of grabbing a spade, keeping it, and then getting a black card? So at first glance, this seems easy peasy, but there is something in here that you need to remember. So a spade, 13 of them. 13 over 52, that's how many spades there are. Great. But if I'm keeping it, I no longer have 52 cards. I have 51 cards. But because a spade is a black card, there are no longer 26 black cards. There's 25. So because spade is a black card, I'm removing a black card from the deck. Now there's 25, not 26. And now there's 51 total cards, and not 52 total cards. And I'm going to do exactly what I did before. Again, because I've done this a billion years, I know that 13 over 52 is the same thing as a fourth, because a fourth of the cards are spades. I don't know how to simplify 25 over 51. I don't think you can. I know you can't. So I'm stuck here. 1 times 25. 25. 4 times 50. 1 is 204. And you can actually not simplify that. So that's just your answer. And again, if you multiply the top and the bottom, I don't care. Just get to a correct answer, however you like to do it. If you're really nervous about simplifying, don't simplify. I'll do it for you. Don't worry about it. Again, thank you for watching my video, and I hope this helped. We'll talk to you guys next week. If you have any questions, email me. We can set up Google Meet if you would like. But thanks. It's been 22 minutes, so I'm good to go. Bye, guys.